Hello viewers, in this tutorial we'll be looking at the addition and subtraction formulas for trigonometric functions. So we'll begin with the formula for sine. So I'll just write down the formulas. If you have sine of a plus b, it's nothing but sine a cosine b, then plus cosine of a, then sine of b. Then if you have subtraction, so if you have sine A minus B, it's just sine A cosine B, then minus cosine A sine B. So you notice that what? If you have plus here, if you have addition here, it's still addition here, but the sign, you have sine and cosine will interchange. So let's see if we have another situation. What if we have cosine? Let's see what happened for cosine. Are we going to have the same? Okay, let's use green. So for cosine, you have cosine of A plus B. Cosine will have to finish its operation, so it will be cosine of A. Still, you still have cosine of B. But now, if you have addition here, it becomes subtraction. So you have minus, then it will give you to sine. So you have sine A, then sine B. Then if you have cosine of A minus B is now cosine of A cosine of B. So for tan, we have something like this. If you have tan of A plus B is, we have tan A plus tan of B. So if it is plus here, you see it's still plus, but now you divide by 1 minus. So if it is addition here, the denominator will become subtraction. So 1 minus tan A tan B. Then we have tan A minus B is nothing but tan A minus tan B. But now you will divide by 1 plus tan A tan B. Okay. So these are the sum and the subtraction formula for sine, for cosine, and for tan. All right. So let's see how we can apply this ones. So for example, let's take one example here. Let's say we are asked to find, let's say example one. And let's say we want to find the value, find the exact value of, let's say here we are looking for sine 15 degree. So what is sine 15 degree? We can write sine 15 degree. We don't know the exact value, so we can write it as sine of 60 degree minus 40 minus 45. This will give us what? So all you need to do is try to write 15 as either the sum or the difference of two known angles or two famous angles. So we know 60 and 45, they are famous angles. So we can write it in this way. And now this becomes, based on our formula, this will become sine. So you see this as what? A, and this as B. So if we go to our formula, of sine, you see that for sine, we'll have sine using this one. Since we're dealing with, we'll use the second one. So it will be sine 60, then cosine of what? 45, then minus cosine of 60 degree, then sine 45 degree. And that's it. So all we need to do is to find the values. These are known. Sine 60 is root 3 by 2. Cosine 45 is root 2 by 2. Then minus cosine 60 is 1 over 2 times sine 45, root 2 by 2. So this will be root 6 over 4 minus root 2 over 4, which will give us root 6 minus root 2 all over 4. So this is the exact value. Now, let's take another example, say B. Let's look at now sine of 75 degree. We can write it as what? We can write 75, we can write it as the sum of 60 degree plus what? Plus 15, yes? But 15 is not a famous angle, so it means we cannot do this. So we need to think of something else. Now we can write 75 as what? As 30. So we can write 75 as 30 degree plus what? 45 degree. Then here, since we're using addition, it's going to be sine of what? 30 degree cosine of 45 degree. Then it will be plus. Then now cosine will take charge. Cosine will start. Then sine will finish it up. But you see, this is plus, this is to remain plus. It's not going to change. So now what is sine 30? Sine 30, it's 1 over 2. Cosine 45 is root 2 over 2 plus cosine 30 is root 3 over 2 as well. Sine 45 is root 2 over 2. So here we'll have root 2 over 4 plus this will root 6 over 4. And this will give us root 2 plus root 6 all over 4. So this is the exact value of sine 75. Okay. Now let's take another one. Let's say C. C now, let's go with cosine. So we have cosine minus 105. Now we know cosine is what? Is even. So this is still the same thing as cosine 105. And we can write this as cosine of what? 60 degree plus 45 degree, right? So now, but if you look at the formula for cosine, you see that if you have addition, cosine will always finish its operation before it gives it to sine. So we're going to use this one. And if this addition, here becomes what? Subtraction. So now this will be cosine of 60 degree, cosine of 45 degree, minus, what else again? Sine will take over now. So it will be sine 60 degree and what? And sine 45 degrees. And what do we have here? What is cosine 60? It's 1 over 2. Cosine 45 is root 2 over 2. Sine 60 is root 3 over 2. And sine 45 is root 2 over 2. So this will give us root 2 over 4 minus root 6 over 4. And this will just be root 2 minus root 6 all over 4. Okay. Right, so let's take another one, maybe for tan. Let's take for tan now. Let's take for tan. I call it D. D. Or we can still, yeah, let's take for tan. This one, let's say we're looking for tan. Let's say we want tan of 37 pi over what? Over 12. So if you look at 37 pi over 12, you see that the angle here is already what? It's already bigger than 2 pi. So the best thing is to go for what? Coterminal first. So we go for coterminal. How do you go for coterminal? This will just be the same thing as tan of 37 pi by 12. We can remove 2 pi first, right? This is nothing but coterminal. So this is going to be tan of, let's go this way. So this is tan of what? 37 pi. So we'll have 37 pi over 12 minus, this is going to be 24 pi over 12 as well. And now this is the same thing as what? 13 pi over what? Over 12. Now, if you look at 13 pi over 12, it's not something you can easily get. But look at 13 pi over 12. You see this angle is in which quadrant? You see 13 divided by 12 is already greater than what? It's greater than 1. So it means 13 pi over 12 is going to be in quadrant number 3. So because any angle greater than pi, yeah, it's greater than pi, but it's not going to be in the fourth quadrant. So remember, you have this is pi, and this is what? 3 pi by 2, right? This is pi by 2, and this is 0 and 2 pi here. So you see, since the coefficient here, 13 by 12. So 13 by 12, we know is greater than what? What is the coefficient here? Is 1. 13 by 12 is greater than 1. So it's either you are here or you are in the fourth quadrant. But now you can decide to compare 13 by 12 and what? 3 by 2, which is this one. And if you multiply 2 times 13, you will see you have what? 26, right? And if you multiply this 12 by 3, you are going to get what? You get 36. So you see 26 is less than what? 36. Just look like you're doing cross multiply. This is how to compare fractions. So it means that what? 13 over 12 is actually less than what? 3 by 2. So it means we will be in the third quadrant. Now, being in the third quadrant, then we can find reference angle. We know tan is positive. So this is going to be tan. And here we'll have, how do you find reference? You subtract what? 180 because we are in the third quadrant. So this is going to be tan of what? This is 13 pi. Is going to be minus 12 pi over 12, right? And this is just going to be tan of what? This is going to be tan of pi by 12. You see? Now you have tan pi by 12. So pi by 12, definitely we don't have the exact value. So we have to think of how to break this number to something we can use. But if you look at pi by 12, you can decide to convert pi by 12 to degree from radian by multiplying by 180 over pi. So if you take it to 180 by pi, what happened here? Pi will go with pi. So this is 180. You can have 6 here to give you 2. You can have 6 here to give you 3. So you have 30 divided by 2. This is 15. So this is actually tan of what? 15 degrees. Now you have tan of 15 degree. Then you can write this as what? As tan, as maybe either the sum or the difference of two famous angles. But we can write this as 30 degree minus what? 45 degree. Okay. So now you can use the difference formula for tan. And now look at the difference formula for tan. You see, you have tan A minus B is going to be tan A minus tan B over 1 plus tan A tan B. So if we go back here, with this we can write as what? Tan 60 degree, right? Then this will be minus tan of what? 45 degrees over 1 plus tan 60 degree and what? Tan 45 degrees. All right, so now we need to substitute the values. So what is tan 60? Tan 60 is root 3. Tan 45 is 1. And here you have 1 plus tan 60 is root 3. Tan 45 is 1. So what do we have here? We'll have root 3 minus 1 over 1 plus root 3. And this we can rationalize by with 1 minus root 3, 1 minus what? Root 3. So this times this will give us root 3. This times this will give us, okay, this times this will give us root 3. This times this will give us just what? Minus 3, right? Yep. Then minus 1 times minus 1 is minus 1. Minus 1 times this. This will give us plus root 3. Then denominator is just going to be 1 square minus what? Root 3 square. That is difference of two squares. So you will have this plus this will give us what? Okay, let's see. Minus 4 minus 3 minus 4. Minus 3 minus 1 is minus 4 plus what? 2 root 3. Then the denominator will have 1 minus 3, which is just going to be minus 2. Okay. Now, if you divide this, what do we have? Just divide. This will just be minus. We'll have 2 minus what? Minus root 3. Yep. So here, what is happening here is just, okay, let me just go one more step. This you can write as minus 4 divided by minus 2 plus 2 over 3 divided by minus 2. This and this will give us 2. This minus will make here minus. 2 will cancel 2. So you just have this one. All right. So do we still have another? Yeah, let's take one more question now. So look at this question now. Let's call it E. This is more like a general one. It says we should find the exact value of cosine 3 pi by 7, then cosine 2 pi 21 plus sine 3 pi by 7 and what? And sine 2 pi over what? 21. Now, if you look at this one, you will see that here, you see that you have sine. You see here you have cosine, you have cosine, you have sine, you have sine. So it means that there is no alternate, you are not having sine and cosine. So anytime you have this expansion where you have cos before sine, you should think about cosine. So if I take you back here, you will see we're in a situation like this where you have the green part, you have cosine before sine. There is no interchange between how sine and cosine interchange to operate. So this gives us an idea that this is not going to be sine, it's just going to be what? It's just going to be cosine. But since here is what? Is addition, it's going to be cosine of, so you should see this as your A, this angle as your B. You see that this 3 pi over 5 is still here. It's the same 3 pi over 5 here, 3 pi over 7, sorry. And this 2 pi over 21 is the same angle here, which is B. So this now, you can see it as cosine A. Since here is plus, it's going to be here is going to be minus. But what is our A? Our A is what? Is 3 pi by 7. While the B is what? Is 2 pi by what? 21. So this is what is going to be. And if you want to be sure, try to expand this and see. What do we get? If you expand this, you will have cosine 3 pi by 7. Then cosine 2 pi by what? 21, since you are dealing with cosine. Since here is minus, it's going to be plus, which is going to be now sine 3 pi over 7, sine 2 pi over what? 21. Okay, so you can see you can recover this, you can recover what we have. But this is not what we are looking for, because we want to find the exact value. We don't want to expand anymore. So this is what? This we can write as cosine of what? This is 21. I can multiply both up and bottom by 3. So this is 3 by 3 pi over what? 3 by 7 minus 2 pi over what? 21. And this easily becomes cosine of what? 9 pi minus what? 2 pi over 21. And this is going to be cosine of what? 7 pi by 21. And what is cosine 7 pi by 21? This we can easily reduce it. 7 by 21 is just pi by 3. And here you can see cosine pi by 3 is the same thing as cosine of 60, which is 1 over 2. And we're done.